Hi, welcome to Knowledge Center. As we are discussing regarding the microcontroller programming, today in this video I am going to tell you how to write a program to convert a number from hexadecimal to ASCII. So in short I can say we are going to deal up with the conversion programs. So before taking up a program, let me tell you the logic behind the conversion. Once you understand the logic, then it will be easy for you to implement it using a microcontroller assembly language. Okay. To understand this concept, watch this video till the end. Right. So here I have written a concept, a table here. Look into this. We are writing a program to convert hexa to ASCII. So I have written here hexa numbers and respective ASCII numbers are written here. In hexa, we are going to deal with the numbers 0, start from 0 to F. As we know that 0 to 9 and then we get A to F. So these are the numbers we deal with in hexa. Now if I give this input, what has to be its ASCII conversion? First you need to know that. So in ASCII representation, 0 means it represents as 30. Up to 9 means if it is 1 in hexa, in ASCII it should be 31. If it is 8 in hexa, it should be 38 in ASCII. So these are the predefined values. If it is 9, in ASCII it is 39. Okay. So up to this point, see I will put a line here. You need to understand there is like change here. This is changeover point what we can say. After 9 we have A in hexa. If it is a capital A in ASCII, it will be represented as 41. Right. So after 39 we won't get 40. 40 is reserved for a space. So 41 is for capital A. If I write B in hexa, in ASCII it has to be 42. Similarly, if I write F in hexa, it has to be 46 in ASCII. So this is what actually we need, right? So if I give these inputs, I should get respective outputs over there. Now question comes how to achieve it. So very simple thing, how you can look into this part. If I give a 0, I should get 30 means what has to be done? Add 30, as simple as that. So plus 30 has to be done to get it ASCII. If I give 1, again you should get 31. So again you need to add 30. Similarly, you compare from 0 to 9, you just need to add 30 to get the ASCII conversion of hexa. So if the digit, if the input what you are giving, if it is between 0 to 9, just add 30 to that. That will give you the ASCII number. That is one point. If I give more than 9, means after 9 we get A, B, C, D, E, F. If I give these numbers, then the conversion is 41. If I give A, I should get 41. This cannot be achieved by just adding 30. So what we do here, to get this 41, we can add plus 7. First you add this digit with 7. A plus 7. Let's see what is the number. A. After A, you just add 7 numbers. B, C, D, E, F, 1011. 1011. So 7 numbers I added. So what you got? 1, 1. So after, if I do A plus 7, you get 1, 1. Then for that result you add 30 plus 30. So 1, 1 plus 3, 0. You get 4, 1. I got the number. Right. So this logic remains same for A to F. If you want to get 46, if I give a F, I should get 46. So to do that, I should add a plus 7 plus 30. That is the only difference here between this and this. Okay. F plus 7. So let's see what is the number F. After F, you get 10, 11, 12, 13, 14, 15, 16. Okay. After 16 plus 30, 16 plus 30, it's a 46. So you got 46. So here you should understand that the data what we are giving, if it is less than or if it is less than A, just add 30 to that so that we get the ASCII values of it. If it is equal to or greater than A, then you should add 7 plus 7 first and then add 30. So you get the conversion of it in ASCII. So this is the logic. Now let's see how this has to be implemented using microcontroller programming. Already I have written a program here. Keep this point in our mind because I am going to erase it now. So keep this logic in our mind and then move on. So I will tell you how we got this program. Step by step let us understand. Okay, so let me erase this. Okay, now let us give one input. First let me take one input. And one more important thing, microcontroller is an 8-bit register. So I can give two hexadecimal numbers. Example, I can give the input like this, 3C. So this is the input. Now convert this into ASCII. So this is a hexa number, this is another number. Two separate numbers has to be separated now. You cannot take 3C combinedly and separate it. So if this is the possibility, if this is the input, let's see how to convert it. So I should give the input at certain location. So let me tell you the logic and then we'll come to the programmer. I told you what is hexa and what is ASCII conversion. What do you want to get? First I explained you what is input, what is output. Now I am explaining you how to achieve it, how to get that. So if this is the input, 3C, if this is the input, what you need to do? First you have to separate the numbers. So to separate that, first let me take it into accumulator. So let's say somewhere I will give the input in a register, some internal memory. So let me give the input at 50H. So I want to give the inputs at 50H at this location. So my input is 3C. That is the hexa number. I want an ASCII of it. Okay. So what is the ASCII value of C? ASCII value of C is, so answer what you want. C means, A means 41, B means 42, C means 43. So for C, you should get it as 43. So you have to separately take it. And for 3, what is the ASCII value of 3? If it is 3, just add 30, you will get 33. So for 3, you should get the answer as 33. Let's write a program for this. First, let us take it into accumulator. So what we have done here, I have assigned a register R1 for 50H. Because I am giving the input at 50H and I will assign this number to register R1. That has been done. And after that, I will take this into accumulator. That's what my intention. Whatever the number I have, I want to convert means you take it into accumulator first. So move A comma at R1. So R1 is 50. At 50 what I have? 3C. That will be given to A. So accumulator will have the input. Now temporarily you store it in some other register. Because in future I want this number again. So I move that data to R2. That's why I am using this line here. Move R2 comma A. So the A, what is the A now? A is having this input 3C. That will be given to R2 temporarily. And now we have to separate these numbers. You have to separate these numbers. Accumulator is having 3C input. Now just take C and convert it. Okay. So I don't want 3 now. I just want the lower nibble. See, this is an 8-bit. If I write 3, it will be like this, 0011. If I write a C, C is nothing but what? In decimal, it is 12. 808100. This is 12. So this we call it as an 8-bit register data. But if I split it, this is a nibble, this is another nibble. 4-bit data is called as nibble. And I can say this is a lower nibble, this is a higher nibble. Okay. So now I just want to separate, this means I want lower nibble. Let me remove this higher nibble. So I want this as a 0C. So to do that, we use an instruction called AND logic. ANL. AND logic. So whichever AND logic is nothing but, I hope you know the concept of ANDing. ANDing. So I'll tell you that. And whichever the data you want, you keep 1 over there. Whichever the data you don't want, you put 0 in. For example, here I have 3C. I just want to have C now. So let me tell you how to do that. This is 3C. In decimal, you can write it like this. In binary, you can write it like this. Sorry. So I want, what you need now, I want only C, not 3. So I need this. I want A is equal to 0C. I want only lower nibble and I want to convert that. After that, I will take the higher nibble and I will convert that. That's the concept. Okay. So how to do that? First we have 00111100. This is what we have in accumulator. Now I use the logic called AND logic, and I AND this number with AND this 3C with 0F. So that is what the instruction we have written here. ANL A comma 0F H. And the logic A. What is in A? 3C with 0F. So let's see what's going to happen there. This is 3C. Now let me write 0f here. 0f means 0 0 0 0, f means 1 1 1 1, that is 15. Right. Now apply the AND logic for this. 0 and 1. When you recall the AND gate, logical gates, 0 and 1, it will be 0. If any one input is 0, then output will be 0 in the AND logic. 0. Here both inputs are high. 1, 1. 0, 0, 0, 0. So what you got here? This is 0, and here 8 plus 4 is 12. In Hexa, it is C. So this is what you are going to get in accumulator. So once you write this ANL logic here, I use this ANL logic just to separate these two numbers. I want only lower nibble. So what I made now, I have masked this. I have covered this or masked. Okay. So how to do that? You put 0 in these 4 nibbles. So once you AND it with 0, you will get 0 only. So higher nibble is removed and you got only the lower nibble. So after this instruction, what you got? A is equal to 0C. Now I got C. I just got C and convert that into ASCII. Okay. So to do that, we are using a subroutine program because we know that first I need to write a program for C, conversion for C, and then I need to convert 3 also. So 2 times I require a conversion. So instead of writing 2 times, I'll write 1 time and I make it as a subroutine program. Okay. So I will call that subroutine program using the instruction ACALL. Okay. ACALL ASCII. This is a subroutine, and here we have that program. So it will jump. The program will jump to this line now. It will not execute this because we are calling this ASCII. So it will jump this concept now. This is a conversion program. Here just we have taken the data and we have taken this lower nibble whatever we want. Now here actual conversion will take place. This is subroutine program. This has to be written after end. Okay. So let's see what's going to happen here. So how to convert it? Now first you need to check the input what I have given, whether it is greater than A or lesser than A. You need to check it. If it is lesser than A, what we had told in the earlier point, if it is lesser than A, just add 30 to that. If it is greater than A, you should add 30 as well as 7. Now this is greater than 30, so you should add 30 as well as 7. Now by looking into this as a human being, we can say this is greater than A. But a machine will not just understand by just looking into that. So we have to apply some logic there. So let's see what logic we have used here. Only simple thing, you will jump to this, and what we do now, this data will be stored temporarily again in R4. So I will store that into R4. So R4 will also have 0C. Go through this process clearly because I am writing a step by step. If you miss any one step, then it will be a confusion for you. Okay. Take that R4. R4 is 0C. Right. Then clear carry. So carry flag will be 0, 0. It will be cleared because the carry flag is important here. We need to check that carry. So that's why I am clearing it. Then subtract. So what I am doing here is subtract A comma 0AH. So just a minute. A comma 0AH. Now you should understand why I am subtracting this 0A with accumulator. I told you earlier I had just drawn one line. So 0 to 9 you should just add 30. Once if it crosses 9, if it is A to F, you should add 7 plus 30 to get the answer. So this is the, what we can say, changeover condition. So if the input is, once if I subtract it like this, if the input is lesser than A or greater than A, that can be checked using this instruction. Let's see. What happens here? Subtract A comma 0A. What do we have in A? Accumulator is having 0C. Okay. So here 0C minus 0A. So you get some answer. C minus A, you get 2. Here this answer is not important for us. We don't want to subtract. We are checking the carry flag here. Why? I'll tell you. See, what will be the carry? If a larger number is subtracted with a smaller number, then we won't get carry. So what will be the carry flag? It will be 0. We don't have carry now. Okay. So if there is no carry, I can make a conclusion that the accumulator what we had, the data what we had in accumulator, that is greater. That is greater than what? That is greater than A. If it is greater than A, then you need to make a condition, you need to make a decision that if it is greater than A, you need to make a decision that you should add 7 as well as 30. So you will check us, now I will check this carry flag. So according to this, once we subtract, there will be a carry generated and there will be carry flag affected, and carry is not generated here. Carry is 0, right? Because the accumulator value is greater than A. So we will not get carry. If there is no carry, then what I need to do? If there is no carry, then it means that it is greater than A. So you should add 7 and also add 30. So I have written that condition here. Before that, you should write this line here. So this is most important. Move A comma R4. So let me tell you what is actually this is. See here, once you subtract, you got accumulator as 02. Whenever you subtract the data, the result will be stored in accumulator. So once you subtract this, accumulator will have this number 02. But I don't want that 02 here. I am subtracting only to check whether there is a carry or not carry. Okay. So based on that carry, I am deciding that whether I should add 7 plus 30 or I should add only 30. Okay. So here, this is not required. So, but it will be changed because of subtraction. Accumulator will get this number. Now what I need to do, I should recall that what I should have in accumulator now. I should have the original value, that is 0C. So where do we have that 0C? In R4. So that's why we have stored it temporarily here. Now I'll recall. So accumulator will get 0C again. So what happens now? Accumulator, I'll write it here. Accumulator will get 0C, the original number, into it. Then check for carry. If there is a carry, then just add 30. Because if there is a carry, it's less than A. That is an indication. Now I don't have carry. So that's what I have written. If there is a carry, jump to next. Next is to be written here. It is missing, I'll write it here. Next has to be written here. Means I'm just keeping this 7. I'm not adding this 7 to accumulator. If there is carry. But now we don't have a carry. Here the carry flag was 0. Because this is greater than A. So if there is no carry, it will come for the next line. So according to this program, there is no carry, so it will come for the next line. Add A comma 07. What is A? It is C. C plus 7. C plus 7, what will be the answer? D, E, F, 1011, 1213. So 13 will be the answer. Then again next step is add A comma 30. So 13 plus 30 is 43. So I got that 43. I told you that if it is C, it should be a 43. We got 43 now, isn't it? So we got 43, but you have to store somewhere now. So we got the answer. We got the converted number now. Just go back to the main program now. Return. See, every subroutine program has to be ended with RET. That is return. So return instruction, when it executes, it will come back to the next line where we have stopped it. So it will come to this line now. Program will come back to this line and increment R1. So R1 was 50. Now that R1 is going to become 51. So we got R1 as 51. Here I am going to store the answer. That's it. So answer was in A, accumulator. So once whatever the addition or subtraction you do, result will be in accumulator only. So what was the result? It was 43. So that I am taking it into R1. So move that answer into R1. R1 is 51 at R1. So I will get hit here. So we got the answer of C and I have stored it at 51H. Next I will take 3 and I will convert that into ASCII and I will store at 52H. That's the concept. Okay. So we got this. Next I want to check for 3 now. So again recall this into accumulator. Get this back into accumulator now. Where do we have it? Where do we have that 3C? We have that result in R2. So temporarily I have stored in R2. So we have that 3C in R2. So I will call it back. So here I have written that line. How to get back that value? Move A comma R2. So R2 is having the result, the data 3C. That we got it into accumulator. So now you can say again accumulator is having 3C. Now I just want 3. I don't want 3C. I want 3. Right. So we can apply AND logic. But one thing I will tell you. I don't want C. So here I will put 0. I want 3. So there I will put F. Okay. I will put all the bits as high. So before that I will tell you what you need to do. If I do that, what you get, if I AND logic, if I apply the AND logic with this, with a 0F, then you get it as 30. I don't want 30, I want 03. So what I do, first we will swap. We have an instruction called swap. So we have written that here. Swap A. So swap is nothing but what? It will be like this. What is happening here? In a swap instruction, the lower nibble and higher nibble are interchanged. See, the statement is very clear. The swap instruction, what it will do? Lower nibble and higher nibble are interchanged. So lower nibble will come at the higher nibble position, higher nibble will go at the lower nibble position. So this is the point. After swapping it, now apply ANL A, 0FH. So now AND this with a 0F. So C is nothing but 1100, 3 is nothing but 0011. And this with the 0F. So we have it in accumulator and I will add it with 0F, 0F. What remains? 1100, all zeros here. So you got 0 and you got 3 here. If you don't do this swap, you will get 3 here and 0 here. That means 30. I want 3. So first you have made a swap and then we go on for an AND logic. I hope it is clear. See, if you are understanding the concept, press the like button over there. Okay, like icon, you just click on that. Right, and also put a comment over there so that it will boost up our energy to do some more videos. Okay, now we got 03. Now just convert it. So this is the conversion program. So call this program. So accumulator is having the 03 and now a call ASCII. We call this program. It will jump to this program now. Okay. Now temporarily store it into R4. So R4 will have 03. Then clear the carry. Subtract A. So what do we have in A? We have 3. A minus 0A. So 3 minus 0A. We get negative number now. Definitely we get a negative number. I am not bothered about the answer. So forget about that. We get a carry here. We get a carry. Yes, we got a carry. So that will be 1. Carry flag will become high. Okay. So if there is a carry, we got carry because the content of accumulator is less than A. That's the reason we got carry. So now what we need to do? You should check for a carry. Before that, you get back this 03 into accumulator. So I have written this line. So we got accumulator as 03. And now check for carry. Yes, there is a carry. If there is a carry, jump to this line. Skip this. Now I am not executing this. I am not adding 7. If there is a carry, the number is smaller than A. That is an indication. If the number is smaller than A, then just add 30. Skip this line. So that's why we use the jump carry here. You should not use J and C. So come here, add A, 30. So A is 3 plus 30 is 33. And you got the result. Where do we get that result? It will be in accumulator only. Then return back. So now this return instruction means you will come here. Increment R1. I want to store it at 52H. I want it to store it at 52H. So we are incrementing that R1 and the result has to be moved to R1. So move at R1, comma A will be the next line. Move at R1, comma A. So here we get 33. So this is the conversion of C. This is the conversion of 3. This is an ASCII of C. This is the ASCII of 3. That is how we got the result. And then you short jump and end it. I hope this is what you got an idea about it and it is clear for you the way of converting the hexa numbers into ASCII numbers. You just take some other example and analyze the program so that it will be clear for you. Okay, thank you.